So we're going to talk about mechanics of metrics, which means we're actually going to talk about the numbers today, specifically how dimensions and stuff work. So hi, I'm Erin. I'm at Red Hat now. I was at IBM forever. I run Dungeons and Dragons for my kids, and I build ludicrous things in my spare time for fun. So we have been talking about metrics a lot lately. Lately is a weird term. This paper was from 1992. We always talk about metrics when we talk about distributed systems. And the ultimate question is, why do we need these distributed systems to be observable? I think everyone touching cloud computing in any way or distributed computing in any way has seen the fallacies of distributed computing by now. We all know that these things are not true, but we know that our human brains like to think that they are because it's a simpler system to reason over. Recently, I say with a question mark, because it's been like almost a good 10 years now that we've been talking, like a cold 10 years that we've been talking about microservices, it feels like. We're still coping with that. But it's a much more complex landscape than it was 15 years ago. I used to work on WebSphere application server, so I know the old way. This is a much more complicated landscape. We are about at the place where we decide this is too hard and we're going to centralize everything again. You know how this cycle goes, right? So we're about back to when we've decided the chaos is too much and we're going to come back together again. But there are a lot of pieces. And having all of those pieces really requires good automation, an observable system so that the automation can work. We want to do workload scheduling. We want to be able to do as much balancing as we can in an automated way. We want the alerts because there's just too many pieces, right? You really actually have to have an observable system to allow this automation to work. The advantage we have right now is we have a little bit more consistency. Well, we have a different kind of consistency for work. Like when I worked on the application server days, if it was all WebSphere ND, it was certainly all the same kind of work, right? But it was monolithic in that everything had to fit in that shape. You couldn't easily manage JavaScript applications with WebSphere ND. Didn't work. Now we have containers. So we actually have several different kinds of containers at this point. We've got like OCI images. We've also got WASM, which is kind of container that's coming to be. And so we've got a couple different container shapes that are floating around. But that has really allowed us to do more consistent operations, which again feeds into this revitalized conversation around observability. So if you guys take nothing else from my talk, go read this blog post. It's real easy to search. It's on Medium. It's a quick read, 8 minutes. I love it. And I shared it with some of my friends. They're like, oh, but isn't it just like reaching for stardom from Buzzword Bingo? And it's like, well, kind of. But I really enjoy some of the nuance that's put forth by this. So we've talked a lot over the last few years, especially as OpenTelemetry has evolved, about the 3 pillars of observability, which is tracing and metrics and logs. What I like about this is it makes that picture a little more robust. So you still have tracing in there, where I hope by this point we realize that like tracing is the holy grail of entire cross-system, what the heck happened to my work as it flowed through the system that I know that we wanted to try to build in WebSphere in 19-something. But it was really hard to get those cross-component contexts to actually flow all the way through. Getting everybody to participate was nigh impossible. There were just too many pieces. But now we have things like Jaeger and Zipkin and OpenTelemetry now that have evolved from those, where we actually have agreement from everybody like, yeah, we're going to have these span tags and we're going to propagate them. And it's like, finally, we can trace the work all the way through. This is amazing. And when we're talking about really complicated distributed systems, that's really important. How many of you have seen all of the memes like it was the DNS? It's almost always the glue between, right? So you're following the work all the way through the system, and a lot of the times your problems are somewhere, it's not the one service, it's the space between the services. And the only way you're going to find that is if you can trace the work all the way through and find out where some of these things are happening. That's why traces are important. I love the definition, the clear distinction that he's making about events. Because we now talk about events. We don't have enough nouns. Has anybody noticed in computing we don't have enough nouns? There's just a severe shortage of nouns. So we talk about events, but what he's being clear, like when we talk about events, when we're talking about these distributed systems, we're not talking about every log message as an event. We're talking about change events. We deployed a new service. We updated the DNS records. We decided to upgrade hardware in this data center. Like, this is stuff that's external to the service. It doesn't happen all the time. These are not necessarily as frequent, but they can have really far-reaching ramifications. Those are the events we're trying to keep track of. You keep all of them because they can really destabilize the whole system in unexpected ways. So unless you remember, oh, right, we just replaced the drive in that box over there, and it had the, it tripped this, which tripped that, which tripped the other thing, and then, the whole system falls down later. Go see Roblox outage as a good example. Metrics are what we're going to talk about today. And we're specifically, in this case, talking about cloud platform operational metrics and not user analytics. There's a whole, if you go search online for metrics, there's so many different things that we all talk about as metrics. Key performance indicators are metrics. That's not what we're talking about here. We're trying to look at this infrastructure operational style metrics in this case, within this context. He included, with this nice pronounceable Temple acronym, he included profiling, which for Java folks is really important. We love profiling, we love JFR, we love all that data. When we're talking about these distributed systems, we don't currently have a good way to get that profiling data anywhere else. Some real hacky ways to try to get the profiling data that was captured by the JVM inside of a container to anywhere else that you can analyze it. When we used to have the big servers running on bare metal, you could get to the logs, you could get to the profiling data, you could store it somewhere. If you're running it as a jar on your own, you can get to all this. When it's in a container in the middle of a system in a pod somewhere, securely getting that data and getting it somewhere else is not as trivial. So we're starting to see some activity within the OpenTelemetry project for how to deal with this kind of detailed profiling data. How do we handle it? Where does it go? How do we store it? How do we ship it? Part of what OpenTelemetry is doing right now, which is what makes it fundamentally so interesting, is it's defining a common binary protocol that lots of OpenTelemetry, like lots of tracing backends, observability backends, have all decided to understand. So we're starting to have the common language. Here's how we send tracing data. Here's how we send metrics data, which means choosing your observability backend becomes a lot less invasive to the rest of your system. And so understanding how to deal with this profiling data, like, it makes the whole system more robust. And we've got lots of people who are they are all of the same mind. Yeah, this would be good to handle, but it's non-trivial. Like, what do you do with a flame graph? They're figuring that out, right? It's non-trivial stuff. Now, logs is the other place where this word event comes in. How many of you have heard of Honeycomb as an observability provider? You should go look at their website, what they're doing. They're very disruptive, and I like it. Charity Majors drops maybe more F-bombs than I do. I don't know, it's a race. So they're pushing the envelope of what these observability solutions should do. And so part of what she talks about is arbitrarily wide events, or having these this broad swath of data. And in the end, and this is what I liked about his blog post, is he's like, they're not really talking about events. They're talking about what happens when you have lots of services that all have structured logs, machine digestible logs, rather than human readable, like texty logs, right? Your logs in JSON or YAML or I don't know, whatever thing, so that the machine can digest them and put it all things. But all of these logs coming from all of these places are not schematized to a single schema. So they all have slightly different footprints, and that's where you end up with this arbitrarily wide event, right? Because you can then still chase through and find things and see correlations because all of the pieces of your system are contributing their logs in a very unique way, but you end up getting this very complete picture because each one can be very verbose, very specific to what it's doing. I really like that because when you read things about Honeycomb or when you read stuff that Charity Majors writes, her talking about events gets then entangled with this other notion of events. So I thought the distinction between the two is really useful. The last one is home sweet home for me, and that's exceptions, which he treats as a specialized kind of logging. So I've mentioned before that I worked on WebSphere Application Server. We used to have something called first failure data capture. And with first failure data capture, if an exception happened, we grab the stack trace, we grab the entire, like the whole call stack, all of the objects that were on the call stack, like you got almost a whole heap dump when that happened. And it went into a special file, and we would recognize patterns. Oh, we've seen this exception before. We'll store at most 10 of those exceptions, and we'll try to make sure that they expire so that you have a recency of these exceptions that are recurring, right? So that if you then decide, oh, I really should finally look at this exception now, you have the best chance of still having the logs for it, because of course logs people toss because it's a lot of data. I think that's a really great picture, right? It's a really great picture of context for what all these observability signals are for and for how it should all fit together. So I love that a lot. So when we get back to metrics, one of the things to know is we're dealing with statistics, which my brain does not like to remember at all. I will reteach it to give this talk. I will walk out of here, ask me later, I won't remember any of it. My brain, it's like oil. It's not retain this, which is hilarious given some of my background. It just doesn't like it. So when we're looking for trends, one of the things that we like to do is we're saying we've got normal bounds, we've got controls. We're going to look at a flow of measurements that we have, and we're going to try to find the outliers. Right? That's what we're looking for. And this is why I'm saying I'm amazed that I don't remember metrics because of my own background. I spent a summer working in an automotive manufacturing plant with my dad. It was a stamping plant. They worked designing machinery to take flat metallic blanks and turn them into, do you know what that is? That is a roller rocker arm that will get attached to the camshaft that goes into your engine that makes your pistons go, and that's why your car moves. Okay, I'm sure you all knew that. So when you're manufacturing those kinds of parts, because this is a third-tier supplier, as they call it, so we're making the rocker arms, which then goes to the next plant, which puts the bearings in and attaches it to the camshaft, which then goes to the next plant, which puts it in the engine with the other things, right? Whatever those things are, don't ask me. That means we have to, like my dad's plant, that whole process had to produce parts, not perfectly. These are physical objects, right? There's slop, there's tool variations, there's all kinds of things. So they're never going to be perfect. They're within tolerance. Those red lines, right? So it's like the perfect is in the middle, and you've got an allowance that you have to be within, and as long as you're within that clearance, within that tolerance, as they call it, everything's great. It'll all go together. Your car won't fall apart. There will be no recalls, no material waste. Life is good. And so what we would do is manufacturing would run all day. They would have lots of parts. They call them lots, like a bin. And I would get 2 out of every 100. I don't remember the exact numbers, but they would come into the quality control office. We would use all of the fine instrumentation that we had to measure very clearly, like all of these really important measurements, which, given that that's not a super, like it feels like a weird shape, but like that little dimple, very specific placement, and it matters. The size of that hole on the top, very specific placement, and it actually matters. So there's things like that. And what we would be measuring, you would be measuring for all those specific things. And what we would be looking for is, oh, this measurement has started to drift. It's still within tolerance. We're still making good parts. But because this measurement has drifted, we now know it's time to change the tools. It's time to change the drill bits. It's time to change whatever mallet thing. It's time to change the tools. That way everything, does this sound familiar? It's exactly what we're trying to do in our virtual world, right? This is exactly what we're trying to do. So when we talk about why we measure things, how many of you have heard these acronyms thrown around? SLI, SLO, SLA. So we're measuring, well, these measurements that we have, these are service level indicators to some extent. To really cover, like to really fall in this boundary, we're really kind of looking at the whole system rather than like one specific piece. What is the whole status of our system? Are we meeting the service level? So there's like a service level agreement, which is sometimes explicit and sometimes implicit. I don't know that Discord has an agreement with me personally about what my expectations are, but I will bet that they have an SLA because they know my perception of whether or not things are right. And so they've set that SLA to say if we exceed that, then they're going to start thinking the server's down, and then the internet will panic. So what ends up happening then is you have an objective, a service level objective that's a little more conservative than what that agreement is. And the idea is, with what you're measuring with these metrics, you're trying to find when you're getting close to that SLO, so you can correct the situation before you violate the SLA. That's how all these things go together. That's why we measure. We don't measure because it's fun. We measure because we're trying to make sure that we understand what the system is actually doing, although that's a bonus. But we also want to make sure we're within control. We're within this expected behavior holistically. So metrics are numbers, fundamentally. They are the most efficient way to store data. When you think about all of those other ways that we talked about earlier as part of Temple, all of those are a lot more verbose, right? The traces are huge, logs, huge, profiles, very detailed. And all of those things, then we start talking about sampling or downsampling. So if you think about traces, sometimes what they will say is, we will keep more of the traces for those latencies that are like a little more out of the norm, not necessarily the total outliers, but a little more towards the outside. We'll store more of those. The ones that are right down the middle of expected behavior in green, maybe we'll keep a couple, but we're going to throw stuff away because it's too expensive. But metrics are fundamentally just numbers. There's a caveat we'll talk about. And so we can store all of it. Which allows us to do some really interesting reasoning about our system. So when we talk about metrics, we're talking about time series. This is, again, like exactly the same thing as what I was doing in my manufacturing plant with physical parts. Every time we take a measurement, it's like going to the end of the series, and we're looking for trends over time. The big thing is you want this collected at regular intervals. These are not perfect. You're always dealing with an aggregation. You're very rarely seeing every single data point. We're seeing, like Prometheus has a scrape interval, and so you might see a sum of what has happened. You don't see every point, but you'll see the sum. Like you'll see the delta that happened. And different backends, different observability backends treat or want that data differently. Prometheus actually wants the raw values. It wants the cumulative sum, the cumulative count. Just please keep increasing forever, and then when you're zero, I'll handle it, because either the server restarted or your counter flipped, right? But I'll deal with it. You just send me that. New Relic and a couple others, they want only the delta. Just please send me the change since the last sample, right? And they work off of a delta instead. So there's some variation in how some of those calculations are done. But you are still working with a very condensed data storage format. It's just a number. Now, we used to have, if you use Nagios, or if you use a lot of graphite, and people still do this, we used to use this more directly hierarchical representation of data where the name had values in it. So HTTP server request 500, or like you'd have maybe the URI and then the 500 or a 200, but it was like in the name, and then you get to your number. And when you wanted to aggregate across that, well, you put wildcards in. So I would get all the ones across that specific thing, which works-ish. The problem is, as these microservices have exploded and you started to get all kinds of people making all kinds of other services, that naming system started to be really fragile because people would want to add stuff. And then you have all of your metrics that don't match because the wildcard patterns don't match. So then what do? Do you have to go rename everything? Do you have to go munge all your old data? Like, what do you do? And so what we're doing now, what most people have done, is they've transitioned to what we call dimensional data, where you still have the number, you still have a key, and sometimes that key still looks like the old hierarchical model because you want something that helps you scope what this is. HTTP, client versus server, requests. Okay, I know what that metric is. Or there's some other ones for database, cache, like there's all kinds of ones, but my brain is not working on them right now. JVM is usually a prefix. You can get into garbage collection versus threads, right? So there's some scoping of a hierarchy for the key still, but there's no values. There's no aggregation by let me use some wildcard pattern match on the key. The key is mostly for your own navigation of concepts, basically. And we put these more interesting changing elements as tags. And what we've basically done is we're not saying hierarchical data is bad. We're saying we're going to decide the hierarchy later. And this is what we're going to play with a little bit today. I made this thing, and I did it a long time ago because my kids made me learn Dungeons & Dragons, and I was going to have to run something for them, and I didn't know any of the rules, and I had to do a metrics talk at the same time, and this is what happened. So we are going to talk about monsters. You're going to have to put your silly hats on and think about dragons fighting plants and everything in between. The concepts are the same. I'm just not going to throw throughput at you all the time because I found that if all you hear is throughput, you actually don't process, at least for me. Charlie Brown voice goes on. It's like I've heard these words a million times. Not Charlie Brown's parents. You knew what I meant. So when I was doing this, anytime you're measuring or you're going to create an application that you want to measure, you always need to ask, what are the questions I'm trying to answer? And this is one of the caveats, considerations that people like charity majors that work on Honeycomb say. Metrics are only good because you can only reason over the data you've gathered. They only really answer the questions you know you want to ask. It's a little bit of like, I have to know what to measure, and then I can work off what that is. Which, in the case of what we're usually trying to do with metrics, where you're trying to say, I want to understand how my system is behaving, I'm writing this application or I'm managing this system. I know what my SLA is. Therefore, I know the questions I need to ask, which means I know what metrics are the most important. And I can have some other ones for details. But you're never going to do diagnostics with these. So the unknown unknowns are not really, that's not what you want your metric system for, if that makes sense. So when I'm thinking about what do I want to learn from this ridiculous monster combat system, I had a couple things, right? Because I didn't know what I was doing, and I was going to have to do this with 10-year-olds, which meant I wanted to know what normal was so I could make sure that I was running things and I was going to bore them to tears and that kind of stuff. Very super important. How long should an encounter last? If I make monsters fight each other, are we talking like 12 rounds or like 2? I don't know what normal is. Tell me what normal is. I have no idea. How does this combat rule stuff actually work? That was less about the metrics and more about me writing an application, so I would inherently learn the rules. That's how application developer nerds work, right? If we want to learn something, we write code to do it, and then we understand how it works. And the other thing I wanted to understand was damage. What's normal damage? How does this stuff behave? Dungeons & Dragons has all kinds of rules about damage, and I didn't know any of them. So I wanted to be able to go into these sessions with my 10-year-old kids, my kid and his all friends. I don't have like quintuplets, I swear. My kid and his friends, and be able to run this and have an idea of what was supposed to be happening. So one of the things I did first, and I'm going to throw these dice in first only because this is the simple counter mechanic, very most basic metric that you have, right? And I knew I was going to have to do a lot of dice rolling. And of course, you want to make sure that you don't mess that up. It's got to be nice. So here's the first example, so you can think about how this dimensional stuff actually works, where I have a measurement, how many times I've rolled the dice. It's a function. How many times have I tried to pull a random number out of the air for dice? But I can disambiguate that by which kind is it? There's 6 varieties of dice for Dungeons & Dragons. Which face did I roll? I theoretically want this to be flat. Like my goal is equal probability for all values for any given dice. And then Prometheus will add on the instance in the job. So I have a Spring app running and a Quarkus app running in JVM mode and Quarkus app in native mode. I haven't added Spring in native mode, but it's like if there was some really cool difference that came out of because I had different flavors of runtime, I would have Prometheus providing me things and I could drill down on that later. I don't have to decide to do that now. I can make that decision later. So when we talk about cardinality, this is the math that we're talking about. I've got 6 types of dice, 20 possible face values, 3 potential jobs, and 3 potential instances. As it turns out, it's actually less than this because that instance and the job value are always the same. right? So they call that coordinated. It's not coordinated omission, except that it kind of is. There's a different word for that that is not here right now. But it is a coordinated reduction in how many tags I have because those two tags vary together, right? So it reduces my cardinality, basically. Okay, now when we use counters, the value is always, always, always increasing. When you use that in a graph, at some point, we're looking at 100,000 dice rolls, it's flat. The slope is gone. And then I simulated a really big outage. I turned it off, turned it back on again, basically. And you could see what happened to the counter. Ka-chunk. Which is not, okay, so that happened, that's great. And then I'm back to this nice, really flat, uninteresting, maybe pseudo slope. We don't look at counters in that way. It doesn't actually tell us anything interesting about the system. What we do instead is we look at the rate of change of that value. And this is the first time we start to lose some data, as you might say, because we're now calculating this as a rate over time. So if you have so many samples, it's going to say how much did it change within this window, right? So you officially have an average. Which means when I look at this, this is approximately the same timestamp as the last one with the big ka-chunk, right? Big ka-chunk. Except now it's this smoother curve that's going on here. And that's, like you can see, it's like a 0.8 to a 0.6. Like this is the 3 different services. I probably restarted them at slightly different times. The lines vary a little bit within this allotted time window, which is normal. This is a 10-minute window. You can see now that chunk is totally smoothed. And it's it starts to show as a decline at that point. And this interval selection matters a lot. So if I go down to 1 minute, it gets more jagged again. If I go up to 30 minutes, it's like gone. Right, so it's like the smoothing really matters, and that depends on what information you're trying to get from these measurements that you have. If I take this counter thing that I have and I put it to requests to seconds, you can actually also see this. But notice in the left, which is a rate of 1 minute, you can actually see the significant dip. That's a problem. That's indicating an outage from throughput. Because my throughput dropped, and you can see it. On the right, I'm averaging over 30 minutes. I turned it off and turned it back on again. It's gone. All of the variability is gone. So when you start reading things about metrics and you hear averages are bad, that's why. It eliminates all of the details when you're trying to find those extremes for your instrumentation. And this is where my purposes in looking at metrics and your purposes for observing a system are maybe in a little bit odds, because I want the average. You want the outsides. You want the extremities, because that's where your problems are. Okay, so if I switch up a little bit, we'll talk about a different kind of measurement. I wanted to talk about combat. How many rounds are there in an encounter? How often do creatures hit or miss? What does average damage look like? What are those questions, right? We're going to do that with the distribution summary, which is from Micrometer, which gives you a sum, a count, and a max. You can also turn on histogram buckets to be server and client gets really confused in this situation, because which part is the server? Is it my traditional application? Is that the server, except that it's feeding metrics to a back end? So is the observability thing the server? It's very confused. My applications, right? I could calculate the percentiles or averages. I could do all of that out at the periphery in each of these instances. The danger is I can then not aggregate those again, because each process sees its own set of metrics relative to whatever is running within it. So if I have an average from system A and an average from system B, they could be off. I can't average those averages. But if I have the raw sums and the raw counts, I can add the raw sums and the raw counts and average the collective aggregate. That's legit. So when you're looking also at histograms versus percentiles, that's also a huge difference. A histogram, if you're calculating just putting things in a histogram bucket within your different processes, those are effectively raw materials. You can aggregate histogram buckets. You cannot re-aggregate percentiles because they're very specific to the behavior of that single process. Your math is done. You cannot do anything else with that percentile after it leaves the system. Something to be aware of. The other thing that a distribution summary will give us is whatever the observed maximum is, which will decay. We'll see what that looks like in a second. So this is what combat metrics look like. After the next 2 seconds, you can play any Dungeons & Dragons thing ever, and you'll win. I'm kidding. There's an armor class style hit. That's the typical, I'm going to hit you with my sword, and you have armor on, and it either hits or doesn't. There's a difficulty class one, which is a little harder to understand, but that's basically the dragon breathes fiery breath at you, and you either dodge it or you die, or whatever, like that. There's a special roll, which is a natural 1, an automatic miss, no damage. And there's a super critical hit, which everybody loves at the table, which is a natural 20, and your damage is doubled. Those are the specials. See, you and I is now all the fundamentals of Dungeons & Dragons. You can go play. Okay, so remember the questions I wanted to ask. How many encounters per round are normal? So over on that encounter side, I'm looking at I'm counting how many rounds are in the encounter. And I've got a couple things that I wanted to see if they were factors. The number of combatants, which could be from 2 to 6. I've got some sample data in there. I call it the size delta, which is like, are there 2 medium creatures fighting or a tiny and a gargantuan creature fighting? Does that change how many rounds there are? Like, is that a big deal? I don't know. Then I had another thought while I was coding thing. I'm like, I have to choose, in the event that there's 5 monsters, how do they choose which other monster to attack? So I had a couple different patterns. They could pick at random, they could pick by health, they could pick. I'm like, I wonder if that does anything. I don't know. I'm trying to figure it out. But my goal and measurement is how many rounds are there per an encounter. So that's what I used as my data points to try to answer that question, my known question. For attacks, I knew I wanted to say, what's average damage? Is there a difference in the type of damage? How often do hits happen? And I'll tell you, I didn't actually include it in this, but having that hit or miss parameter there was, I found some massive bugs. Like, oops, should never have happened. 3 a.m. pumpkin Erin in the middle of the night code wrote that, just bad. Or pretend it never happened. It's just like, how did that ever work? I don't know. Don't know how that happened. So if we look at the rounds per encounter, clearest, can you see? Does the number of monsters matter? Absolutely. The data doesn't even overlap. If there's 6 monsters, it takes longer than if there are 2. Like, no question. And like, if you show this as a histogram, it progresses, like it marches very clearly across the page. There's no question. That one was funny. So now, given that we know the biggest factor determining how many rounds there are is size, or like number of things in it, we'll take that as a caveat, as a complicating factor for the next 2. So when we look at size difference, things get interesting. It's kind of a messy graph. The one thing to note that I have is like that top right is it's a representation of the count. And I have that there so that I can remember kind of a rough indication of my sample size. So if I'm looking at, this is what? 6 to 20, it's 24 hours probably in there. It's like I have fewer of like a size difference of 5. And in the whole list of monsters that I have, there just are not that many tiny, and there are not that many gargantuan monsters. So landing in a randomly generated encounter that has that extreme in it is rare, right? It's just like something for me to keep in mind. I've got a bit of a difference in how many things I have to pull from. But the individual samples, when you pull these out, is interesting to me. So indeed, when you have a big difference, in the bottom left, I don't know if you can see it, there's a lot of one-shots. Dead, which is what you would expect. The gargantuan thing hits the fairy and they're gone. Some of the other ones, when there's a 0 difference, which is that first graph, that's 2 medium humanoids, which is like the biggest pile of monsters that there are, right? You have a very interesting range. Sometimes it's only 3, sometimes it's as many as 12. And when the other ones, they're kind of all in the middle. So it doesn't seem to make that much of a difference. The other thing to note, which doesn't show up here, so in this graph, you'll see I've got it's that interval thing again, right? And I've got an interval of 10 minutes. So you don't see any real extremes there. It's choppy. It's still showing you that they're not particularly regular in their distribution. But you'll notice on the histogram for that big size 5, there's a long tail there. So that information is there. The average eliminated it. The histogram is showing the data at the smallest interval, so you can see that there. That was probably a Tarrasque battling a plant or something that it couldn't hit very well. And it just took forever. So, I don't know. When we're looking at the target selection, here's another case I'm trying to say, well, I've got about an even distribution of like how you choose your targets from that top right. That's good to know. It's very clear that when you only have 2 opponents, it goes faster. It's because you only hit the other person. So that meets the size requirement. The data pretty much matches. It's the same population. What's interesting though is don't hit the biggest thing first, which is the same strategy you should use if you have to pay off a lot of debt. Don't do the biggest one first. Knock off all the little ones. It's a general recommendation, very clear from both the graph and if you start looking at the histograms. The biggest first is the one in the top left, and it's just the most skewed. Like, that's not a great strategy for winning at D&D. The rest, 6 one, half dozen the other. You could do anything. So what I want you to understand with this really strange exercise, looking at how encounters work, I didn't remeasure any of this stuff. It's one measurement, couple tags. But I can look at all this data in a very different way. And if I want to go a little deeper here, but you start getting into sparse data and some extrapolation, I can pin, for example, we know the number of encounters or the number of monsters in the encounter matters. So I could pin it and say, only show me the ones that have 4. Okay, so we'll take that variable out. Now let's see what happens to the rest. But I'm using all the metrics I already have, right? So that's where we start getting the power. Now, when we look at damage types, this one's fun. This is another case I actually showed this. Does anybody have ridiculous art in their hotel room that looks like this graph? I do. When we look at damage types, this is a case where there's such a huge variability in the kind of damage and how much it does that the graph gets super messy. For those of you that care about D&D, though, there's very clear trends. Lightning and poison damage are awful. You don't want those. Don't neglect your Constitution score. What I wanted to show with this one, this is at a 30-minute or this is a 15-second time horizon. And I wanted to show you, and I don't know how clear it's coming out because of screen translation, but because these are not, like every encounter does not have this kind of damage, so it goes back to 0. Right? And you see these cases where it goes back to 0. When you do that average again, when I'm looking at the mean, those drops to 0, again, they get smoothed out. Right? So it's just make sure you understand the ramification of averages when you're doing any of this calculation, because depending on the information you're trying to get from it about the health of your system, you might not be seeing the right picture or the picture that you expect. Now, this is over 30 minutes, so it's a fairly short interval. What's interesting is how disjoint poison and lightning are, poison in this case being the higher. If I look over 24 hours, I still get this nice spiky graph on the left. The average starts to average out a little bit, and you can see like they overlap a little more, but they're still at the high end of everything else. Now, the other thing that we usually do when you're talking about latency, I'm telling you, all this stuff has strict corollaries to the other things you do, I promise. So this is average latency, right? This is what you actually want to do with latency, is you want to look at your max and maybe your min, but usually your max. If something goes super fast, well, actually, if something goes really, really, really unexpectedly fast, you might be suspicious that it's actually just not doing something it's supposed to be doing. That could be fishy too, depending on what part of your development process you're in. But here, I'm just trying to pull the maxes. Like, what are the max of the max across the 3 instances that I have? Actually, at this point, I have 5, but we'll pretend I have 3. So I'm just looking at all the max values. You can see here, lightning and poison aren't quite, there's a whole bunch of other stuff with them now. And that's because when you look at the max over time, I'm getting the critical hits for all of the other types, which actually land closer to where lightning and poison are. So now, one of the things I did want to point out, this is a pseudo latency graph. You can get weird shapes like this in normal request metrics, like normal throughput metrics, where your you'll have a cluster where all of the things, that's where all of your requests are when everything goes well, and there's a little dip. And then there's what happens when things don't go well. So I know the picture I showed at the beginning was a nice standard distribution, nice normal distribution. That is not always the data that you have. You can get weirdly shaped data too. And so then when you're trying to figure out what your min-max are, what you should be looking for, how you want to set up, like what things you need for your dashboards or your alerts, like understanding the shape of your data is important so that you can make better decisions about what's recorded. So, see, 45 minutes. I cannot make this take an hour to save my life. So we know metrics are cheap, right? I think you've started to understand, like you are storing numbers. Where you can get into trouble is that cardinality explosion concept. And that's, I'm going to measure my HTTP requests. I'm going to store the URI because I want to know what endpoint they hit, but I accidentally included the specific user ID. You now have an infinite set that's now way more data than you actually wanted. And that's when we start saying you've exploded things. Within that bound, though, it's like as long as you have a bound bucket, like there's not necessarily a case where you should never use the user ID. Maybe you are in a company where you have 6 customers that are really well known. That's a nicely bounded set. Go for it. Even if it's 100, that's probably okay. It's if you have like infinite, right? That's when you want to use some kind of a templated pattern to reduce the cardinality so you can keep things. There's also different places where your, as data is digested and processed through various backend systems, there's also places where you can merge tags or rename tags or tag values so you can reduce the cardinality if you decide you don't need something to reduce that later. So you don't have to necessarily do that up front. Know the questions you want to answer. What are your service level agreements? What are your service level objectives? What are the most important things to manage or to understand and to monitor? When you turn this on, you will find bugs. Do turn it on, but do understand that your application is doing things you don't think it's doing. Because it's almost inevitable that that's the case if you have never had it turned on before. There will be more bugs than you expected. There will be more 500s than you expected. I will show you some extra things. It's like I'll show you my dice story. I want these nice things, these nice graphs. This is all good. They're all nice and flat. There's some variation, there should be, with the faces, but they're pretty much, it's a one big ribbon, right? I can plot those a different way because I actually don't care that much. All I want to do is at a glance, look, are these roughly in the same? Like I can look across the top, I can look in the middle of the colors. Everything's good. Once upon a time, I did that. Oops. That does not look right. Yes, 3 a.m. in the morning, Erin wrote that code too. Bad plan. But it popped out, and I would not I had unit tests. I had tests for the dice rolls. I did. I missed a whole switch statement, which I would not have discovered had I not tried to say, let me look at my thousands of dice rolls and make sure everything is probabilistically even. Because that's important to make sure my application works correctly, right? That's important for my application and what it is doing. It needs to have fairness in its roles. I mean, not quantum awesomeness. I'm not that serious, but I did want to make sure that this was at least reasonably functional. And I found a bug. There was another case where I made another dashboard and I came out the critical hit, critical miss thing. I had misparsed. Now see, I'm doing ridiculous things because that's the best fun. I had ingested a lot of JSON data. No, actually, I think that was when I first did it and it was XML data. I totally forgot a single plus in the regular expression, so everything had like an armor class less than 9. Whoops. So that showed up as, hang on a second, why am I having more of, why is everything hitting? What is going on? And it was because I had messed that up. I had unit tests, but I had a lot of data. I had a lot of possibilities. I had more possibilities than I could feasibly test myself explicitly. Right? There's like a limit to how many things humans can write unit tests for without just getting sloppy and falling asleep. We just can't do it. There's also a myth. Production is never like your test systems, right? So part of writing good metrics is so that you can see what your system is actually doing rather than what you just expect it to be doing. Because again, most of the time when we write tests, we're testing our expected behavior. We think this is where it will fail, not where it actually fails. Okay, ask me questions because those are fun. Yeah.
How are you exposing the dimensional ability to specific libraries?
Oh, yeah, so my application's all Java, because I'm a Java person. And I'm using Micrometer across Spring and Quarkus. I wrote the Micrometer extension for Quarkus. So those come out. I'm using the Prometheus registry, and it's going to Grafana. So I have, if I want to look, oh goodness gracious, so if I go and look at my code here, of course I didn't pull up anything interesting ahead of time, because that would have been easy. But like within the Quarkus package, my endpoints are real simple. This anything this is what's going to go run this exception, run the exercise. Let me make this. I can make it a little smaller. So here I'm running the encounter, and I'm setting how many. I'm setting the target selector. That's me building the encounter. I create my round results. Here's where I'm calling. I actually use, this is a preference on my part. I use classes to create, when I'm working with Micrometer for Quarkus or for Spring, there's a bunch of things that the Micrometer library will instrument for you. All the HTTP requests, they just get measured, you don't have to do that. We'll do Kafka, we'll do databases, we'll do the JVM, we'll do the garbage collector, we'll do the threads, we'll do we do all the things. When I was looking at how I wanted to measure my application, which is specific to what I'm doing, I chose to use a separate class for this. I didn't use annotations, because that I think litters the code, and I was already looking at the case where I wanted 2 flavors of Quarkus and a flavor of Spring. And so I was like, if I want to swap the metrics thing out, I want to just be able to inject a new bean and have it do whatever the library needs to do. My other Quarkus variant, I have a Quarkus variant that uses microprofile metrics as well. And so it has a different combat metrics bean that does it the microprofile metrics way. So I'm not using annotations or anything. But so like right here, like I'm gathering, I have a function so that when I'm rolling the dice, I just have a callback hook that says, please just let me register, let me count what you did, right? That's where I do the count. When I end an encounter, this is where I record what happened. What was the number of combatants? What was the target selector? What was the size delta? How many rounds were there? The value I'm recording is the number of rounds. So that's the part that I'm measuring the increase of. That's the sum. It's how many rounds there were. It is a distribution summary from Micrometer. That's where I get the count sum max. Yep. I could turn on histograms here with a configuration if I wanted to. I don't, because I'm just deferring the math until later. Prometheus has things that can calculate histograms over data. Grafana, the histograms that I showed you, Grafana was figuring those out. Like I don't feel that I need to do that in my application because I feel like that's very hands-on. If I know the behavior of my application, then maybe I can do it because I know what the expected things are, and then I can do the pre-computation of all the histograms within the various deployments. But I wanted it to give room to breathe and do it later. Here's where I'm looking at the attacker damage. And then I have another smaller one that I end up not using much, which is just whether or not attacks are successful. But that's how I do the measurement. It's not complicated. And I end up looking at that in Grafana. So like I have my dice panels that show me all the things. I'm at 14.45 million dice rolls since I restarted things. I've just been letting it run. So like there's my max damage one for now. See, Poison and Lightning end up having just some really interesting graph shapes because they just do ridiculous amounts of damage. This is what happens. I go to this one, that's damage by damage type. Look at them. Poison, Lightning. There's like this gap, this chasm every time. Oh, that's the last hour. Let's make it bigger. We'll see how long it takes. Still, poison, lightning. I love it. It's so stupid. It's consistent. Oh, no, there's something else that's cool. I was explaining this to my sister. My sister has now decided that she is going to run, so she's running Dungeons & Dragons for her kid and child's friend. And so that it's this one. Is it this one? Yeah, this one. This one blew my mind as a new DM who had no idea what she was doing. So these bottom two, this is like the normal bog standard, I'm going to hit you with my sword hit. It's an AC, I actually hit you. This is the difficulty class. So that's the dragon breathed fire on me, but I dodged. Okay, notice how low that is? So critical hits are this green line. We hit with a natural 20 and the damage was doubled. When you miss a saving throw, when you fail a saving throw, that's a critical hit, kids. I did not really fully appreciate that when you miss, it makes sense. Like when you save on your throw, it halves the damage. So logically it makes sense, but I hadn't really ever fully processed that those are essentially critical hits out of the gate, and then you make them not. So that was like a fun realization for me, which you guys are like, whatever.
Those are those like extreme dips.
Yeah. Yeah. So spell, like these saving throw based hits, these difficulty class based hits, there's like this huge, like they're very spiky because sometimes it's a smaller monster, it just has like a little poison breath or something, like it's small, but then you have like, ancient green dragon, poison breath of doom or acid, whatever, and those will wreck you. So they are very spiky in that way. There's a lot more range to those values, but when I first plotted this, I was like, wait, what? I didn't really, that was my learning, playing with averages. But again, most of the time when you guys are looking at the actual things for your apps, you don't actually want to use averages. You want to use those maxes for the ranges. These can be useful to kind of understand, which is what I'm doing. What are the trends? Like just how generally does this behave? Maybe that helps me hone in on what my SLO or SLA should maybe be. Like maybe that helps me identify what my trends are. Or I could look at it, I know why that red line is so spiky. I understand because of how these attacks are written, I understand what that means. Maybe you try to graph your averages and you realize that kind of pattern and you're like, that makes no sense for what this app is supposed to do. I don't understand why it should be all over the map like that. And that might encourage you to go and look at some other things to understand why it's behaving so erratically. That could happen too.